Hey everyone, today we are looking at section 5.2, which is going to start talking about bisectors and triangles. So a couple of things that we need to look at is vocabulary. There's a lot of vocabulary in this section, and it is really important that you understand the differences between all of the different pieces, especially between both this section and section 5.3. There are very similar things that you need to make sure that you understand the difference. So if you have questions, please make sure that you are asking them. All right, so the first thing that we're going to look at is some of these vocabulary words is when we have more than two lines intersect at a point, those lines are said to be concurrent. And where they intersect is the point of concurrency. So we're going to look at some different segments and triangles, and they are going to be concurrent, and the points that they are concurrent are going to have different names. So the first one that we're going to look at is perpendicular bisectors. So we talked in 5.1 about how if I had a perpendicular bisector, every point on that perpendicular bisector was the same distance to each of the endpoints of the segment. So now what we're going to do is we're going to put that concept in a triangle. So if I look at side AB, this side right here is the perpendicular bisector. So some key things that we look for. I look for the congruent marks on the sides, and I look for the right angle. That is how I know that this segment right here is a perpendicular bisector. All right. I know that it is going to be equidistant to the endpoints of the segment that it bisects. So point P here is going to be the same distance from A as it is from B. All right, we're going to look at side AC here. This is a perpendicular bisector. Again, I see the perpendicular, and I see that this piece is congruent to this piece. That is how I know perpendicular bisector. So then again, from point P here, which is on that bisector, the distance from A and C is the same. If I look at side BC, this is a perpendicular bisector. Again, I see the right angle and the congruent slashes. So I know that every point on this segment bisector is the same distance from B as it is to C. So point B is on there. So what you want you to notice is that when we look at this, all three of the perpendicular bisectors, all three of these red lines, meet at one point, and that will always be true. So the perpendicular bisectors in a triangle are concurrent, and where they will meet is the circumcenter. So I want you to make a note that P is the circumcenter. And that circumcenter is going to be the same distance from A as it is to C as it is to B. So from your circumcenter, the distance to all of the vertices are the same. Okay? Now, let's take a look at where that circumcenter can be located. Okay? The circumcenter is, for an acute triangle, it is going to be inside the triangle. When I have an obtuse triangle, my circumcenter will be located outside the triangle. And when I have a right triangle, it will be located on the triangle, and it will be specifically on the midpoint of the hypotenuse. All right. So basically, just when we're looking at how the triangle is going to work, all right, this is going to give us where that circumcenter is located. All right, so let me kind of show you a little example of how this works. Okay, this is a triangle ABC, all right, and all of these segments here are going to be segment bisectors. So point G is the circumcenter. So if I move this around, do we see here how if this is a right triangle, point G is on the midpoint of the hypotenuse? Okay, if I make it obtuse, it goes outside. All right, so no matter how I move this around, okay, my circumcenter will change depending on the type of triangle that I have. Okay, because what the circumcenter is, it's going to be the center of the circle that is circumscribed about about the triangle. So if I make each vertex on a circle, all right, and I draw a circle around a triangle, that's called circumscribing a circle, all right, because it goes around the outside. All right, so that's what your circumcenter is it is the circumcenter is the center of the circumscribed circle about the triangle. I know, it's a lot of words, don't stress over that, but that's where it comes from. All right, so let's take a look at an example. All right, here I am told these three segments are perpendicular bisectors. So that is important to know, because what's going to happen a lot of times is if you put all of the information on a picture for perpendicular bisectors, sometimes it can make your picture very, very cluttered. All right, so a lot of times they may just tell you, hey, these are perpendicular bisectors, without giving you the right angle and the congruent marks. But if you're told that it's true, we know that this is a right angle, and I know these sides are congruent. I know this is a right angle, and I know these pieces are congruent, and I know this is a right angle, and I know these pieces are congruent. Okay, so when I know perpendicular bisector, I know all of that is true. Now, that makes point Z my circumcenter. And the theorem that we just said is that if I look at the distance from Z to each vertex, I know that all of these are going to be the same length. Okay, so all my highlighted segments here, ZG, ZH, ZJ, are all congruent. So let's take a look at what we want. We want to find the length of segment HZ. So we want to find this length right here. All right, so what I want to notice is GZ over here is 19.9. Well, I know that HZ is going to be the same length as GZ, so HZ is 19.9. Okay? So, that being said, go ahead and try all these pieces. Remember, bisector means those pieces on either side will be the same length. Okay? And all three of those blue highlighteds are the same. So go ahead and pause your video and go ahead and give this a shot. All right, so go ahead and check your work here. Okay? So as we're looking at this, GM is the length that I'm trying to find. Well, I know that ZM is the perpendicular bisector, so both of these are the same. So if this is 14.5, so is this. For the same reason, GK is 18.6, because this is going to be the same length as this. And JZ, again, is one of the blue highlighted. All three of those are 19.9. All right, so now let's go ahead and take a look at it on a graph. So what we want to do is we want to start by graphing the triangle that they give us. So I'm going to start by graphing O right here is at our origin at 0, 0. Okay, R is at -6. So we're going to go back 6, up 0. So this is going to be point R. And S is going to be at 0, 4. So right here is S. So let's go ahead and draw our triangle. And our triangle goes right here. Okay, so now what I want to do is I want to graph the circumcenter. So in order to graph the circumcenter, I need to graph the perpendicular bisectors. All right, so to graph the perpendicular bisectors, we're going to make a list of things here, all right? Step 1 is going to be to find the midpoint of each side. Okay? Because I know it's a perpendicular bisector, so it has to go through the midpoint of each side. All right, step 2 is going to be to find the perpendicular slope to each side. So that means, remember, find the slope and then find the opposite reciprocal, because that takes care of the perpendicular part. Reciprocal. Okay, then we're going to start at the midpoint and draw the line using the perpendicular slope. Okay, so the nice thing here is when I look at this picture, it is a right triangle. Okay, and I have sides that are pretty. They are vertical, they are horizontal, and that makes life a lot easier. Okay, so when you have horizontal and vertical sides, you've got a little bit less work to do. All right, but if we don't have a horizontal or vertical side, like our hypotenuse, then that's when we really need to make sure we go through these steps. So the first thing that I'm going to do with these two sides is I'm going to find the midpoint. And I know that it's going to be here because this is a length of 6. This is a length of 4, so halfway is going to be 2. Okay, so I know that those are going to be where my midpoints are. My midpoint of this one, I can either do midpoint formula, or I can say, hey, I know that it's going to be right here. But again, if you don't know where the midpoint is, use your midpoint formula. So remember, midpoint formula is x1 plus x2 over 2, y1 plus y2 over 2. And our slope formula is y2 minus y1 over x2 minus x1. Okay? All right, so let's finish this one up. So I want to look at the slope of this line. Okay, so for the slope of RS, I'm going to go from R to S, I'm going to go up 1, 2, 3, 4 over 6. So it's 4 over 6, which is 2/3. The perpendicular slope is the opposite reciprocal. So it's going to be negative 3/2. So that means from this point, I'm going to use this slope. So I did the midpoint of RS. I did the perpendicular slope of RS. So I'm going to start at the midpoint of RS. And I'm going to go down 3 over 2. Down 3 over 2. So I'm using this slope, the perpendicular slope, to be able to get that perpendicular bisector. And we're going to go 3 left 2. So this is that perpendicular bisector right there. Okay, I wanted to show you that one because you're not always going to have pretty right triangles. You're not always going to have pretty vertical and horizontal lines. Okay, but when I look at these guys, I have a horizontal line. All right, perpendicular to horizontal is vertical. Okay, here I have a vertical line. Perpendicular to vertical is horizontal. So then I look and I see, okay, where do those 3 points meet? They meet right here, which is the point, we'll just call it P, is at the point -3, 2. And because it's a right triangle, it's the midpoint of the hypotenuse. Okay? So if you have questions on that, go ahead and make sure that you write them down. All right, let's take a look at the next type of point of concurrency that we're going to look at today. All right, the next type of point is the incenter, okay? The incenter is formed by angle bisectors. So again, yesterday when we did angle bisectors, we said that anytime an angle is bisected, every point on that angle is equidistant from the sides of the angle, or every point on that bisector is equidistant from the sides of the angle. So that's what we did in 5.1. So now we're going to take that and put that in a triangle. Each one of these red or orangey kind of dotted lines here, this line and this line, oops, that didn't go very pretty, and this one are all angle bisectors. And we can see that by seeing, okay, these guys are congruent here and here, right? We see those angle bisected marks. That is how we know that each of those segments are angle bisectors. All right. So when I look here, remember we said that the angle bisector was equidistant to the sides. Okay. Well, when I look at this point, Q is on that angle bisector, so it's going to be equidistant to this side and to this side. All right. Q is also on this angle bisector, so it's going to be equidistant to this side and to this side. Q is on this angle bisector, so it's equidistant here and here. So we have an in-center, which is what point Q is. All right, so we're going to make a note here that Q is the in-center. Okay. Then it is equidistant from the sides. Okay, and one thing that's important is make sure that those distances are perpendicular to the side. That is how we measure that distance. So it's really, really important. Make sure you're seeing those right angle marks. All right. Now, circumcenter is inside, outside, or on the triangle, but our in-center is always inside. Okay. Because if you think about it, all of these start at the vertex and go towards each other. So it's never going to move outside the triangle. Okay, your in-center is the center of the circle that is inscribed, meaning it's inside the triangle. Okay, so our in-center is always the center of the inscribed circle. All right, so let's take a quick look at what that looks like. So here we have an in-center of a triangle. Okay, point D is the in-center. All right, this kind of bluish, tealish dotted line, okay, is the angle bisector for angle A. This darker purple is the angle bisector for angle C. The yellower one is the angle bisector for angle B. So as I move this around, it doesn't matter if we go more towards a right triangle, if I go obtuse, if I go acute. Okay, we're back to obtuse. Everywhere I move any of the points, okay, I'm always going to end up with that in-center inside the triangle. Okay? So, that being said, let's take a look at how this works. So, I know that I'm told here that JV and KV are angle bisectors. So, that means this is congruent to this is congruent to this, and that means that point V is my in-center. All right? So the first thing that I want to do is I want to find the distance from V to side KL. So if I were to draw that in, it would be this distance right here, again, making sure that we have that be a perpendicular segment. Okay? We're just freehanding, so it's not going to be perfect, but okay? I know that V is the same distance to each of the sides. Well, V to this side, so VW, is 7.3. So the distance from V to KL is also going to be 7.3. All right. The next thing that we want to look at is the measure of angle VKL. So I'm going to kind of erase this for right now. And I want this angle measure right here. Okay, so I'm going to call that X. Well, I know that this is also X, right? Because this is going to be bisected. So these are going to be the same. If this is 19, I know that this is also going to be 19. So what I'm looking at here is I want to look at the big triangle and say, okay, I know that all of these angles are going to add to 180. All right, so I'm going to do X plus 19 plus 19 plus 106 and set that all equal to 180. All right, so we're going to combine like terms here. X plus X is 2X. 19 plus 106 is 144. We're going to subtract 144 from both sides, and we're going to get 36. And we divide by 2. We're going to get that x is 18. So both of these angles are 18 degrees. So the measure of angle VKL is 18 degrees. All right, if you have questions on that, please make sure that you write it down. All right, so this last side is just kind of putting it all together. All right, perpendicular bisectors are going to intersect at your circumcenter, which is equidistant from the vertices. Your in-center is going to be equidistant from the sides, and in-center will be where your angle bisectors meet. All right, so it's really, really important that you understand these two different things and you understand the difference between them. All right, we're going to add 2 more different types of centers tomorrow or in section 5.3. So please, please, please make sure that you do understand the difference between these two and you are asking any questions that you may not understand on how to identify which one is which or what they mean. All right, I hope you guys have a great day and we'll talk to you later.